Okay, okay, okay. So listen, how's it going? How's life? How's you know? Okay. So how's it going, guys? How's life? How's it going? Honestly, I've missed you guys. I don't know how much I can you know you know. But honestly, it's been such a long time. Last time I ever did YouTube was what? Summer school? Yeah, August. Well, on a different channel, not this channel. But anyways, fuck how long it's been. I wanted to come and just say hi, hello. I ran out of ideas, and so I'm gonna just bring you into my life, specifically study life, because I don't don't see why not. But fuck you. And so what we're gonna do today is, ooh, just more coffee. Uh-huh. Physics. Oh, I know. Wait, don't leave. Come on. Let's work together. Okay, me and you, Fizz. Let's get into that. Let's get into that Newton. Let's get into that Isaac. Gravity, speed, plus radio waves. I don't honestly know what the fuck I'm doing. Let's get into that F net equals MA. Okay, and let's just get down to business. Okay. Honestly, let's go. If you're wondering what I was doing, that's the speed of my own heartbeat. That's how long it accelerates. Honestly, I don't even know what the fuck is acceleration either. But we're gonna learn that today. Let's go. So what we're going to be learning. Let's start from the. What we're gonna learn today is some physics, starting off with Newton's law, because that's what I'm doing in class this month. I have a final evaluation coming in right around the corner, and you gotta get that Newton down. You know what I mean? You gotta break it downtown. Feel me? And what we're gonna do right now, is we're gonna get down. So I already went through this, and honestly, fuck you. I know you guys not gonna learn twice, like one schlit of whatever I'm doing today. And so what we're gonna do is we're gonna get down to the Newton's third law, because that's what we're dealing with lately. And so that being said, shut up and watch. Okay, let's get down to the business. Let's study together, Let's. Okay, Newton's third law. Shut up. Okay, Newton's third law. Newton's law, lesson 4. Newton's third law of motion. Newton's third law, identifying action and reaction force pairs. No, fuck me. Okay, a force is a push or a pull that acts upon an object as a result of its interactions with another object. Interactions, as discussed in lesson 2. Some forces result from contact interactions. Normal, frictional, tangential, and applied forces are examples of contact forces, and other forces are whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the interaction, a force on the chair, again with the chair, and the force on your body, these two forces are called action and reaction forces and are the subject of Newton's third law of motion. The statement means that in every interaction there is a pair of forces acting on the two interacting objects. The size of the forces on the first objects equal the size of the size. Where the fuck? The size of the force on the road equals the size of the force on the wheels or car. The direction of the force on the road backward is opposite the direction of the force on the wheels forwards. For every action there is an equal in size. What? Okay, let's consider the motion of a car on the way to the school. Cars equipped with wheels that spin. As the wheels spin, they grip the road and push the road backward. Since forces result from mutual interactions, the road must also be pushing the wheels forward. The size of the forces on the road equals the size of the force on the wheels or car. The direction of the force on the road backward is opposite the direction of the force on the wheels. What? Okay, yes, opposite to the direction of the force on the wheels forwards. For every action, there is an equal in size, an opposite in direction, reaction, action, reaction, action, reaction, action, reaction, action, reaction, force pair, force pair, force pair, force pair, force pair, force pairs. Force pair. Force pair. Actually, force pair. I swear I'm not high. It's really just the caffeine. Okay. This bus right here. This bus. Right. That HD pixelation right here. I want to know, why are black people still in the back though? Did anyone realize this? Nobody. You got whatever the fuck this is, and then you got E.T. Okay, and then you got that. I see orange hair. Is that the kid from Magic School Bus?
Everyone, please let this be a normal field trip with a friend. No.
And then you got. This is racism. Wait, what's going on? Wait, hold up. What's going on? Whoa. What's happening here? Why is the bus shocked? Why am I seeing red? Wait, what's going on? Wait, what is? Ooh, I'm getting concerned about this picture. Why am I seeing? I see a line hitting the window, and then I see this red. Newton's third law, people. Fuck, I know how to jump off topic. Okay. For every action, there is an equal and opposite reaction. The statement means that in every interaction, there's a lot of action. Can you stop this? On the first object equals the size of the force on the second object. The direction of the force on the first object is opposite to the direction of the force on the second. Force always come in pairs and opposite action reaction. Force pairs. Force always comes. Let's wait. Here's the thing about me. Here's the thing I just realized. When it comes to reading anything, I realize that I actually don't know what I'm reading. This is a problem here. It's a learning process. Get your education. Okay, and what I realize is, after reading this, all I remember is that forces are a pair. I'm definitely not expecting that it's actual pair. Fuck you. Okay, and that force always come in pairs, as in two. There's a two. That's why there's like two pairs. I don't know why they. Is that lipstick on the dude? Wait, I can tell this is a. I don't even know if that's a woman. 2018 people, we don't even know what's even female or male anymore. We just living, just like, look at this luscious beauty. This could be a guy and that could be a woman. I bet you that's like, come on, pink. You cannot find a man with this much of pink lips. Like, yo, damn, he got it chapped. Object equals the size of the force on the second. Is it just me, or does anyone ever get this problem where when they hear the same word over again, they feel like they're repeating the same sentence? You know that feeling, right? Not just me. There should be at least one person out of 100 from whoever's watching this be able to feel this way. The size of the forces on the first object equals the size of the force on the second object. Okay, we established this. That means like two forces. The size on the size of the force. It's not me this time. That is whoever the fuck wrote this has terrible English. You do not say the size of the forces. Okay, you do not say size. I know. You say this mass, the fucking size of the object. You don't say the size of the forces on the first object. The size of the forces on the first object equals the size of the force on the second object. The direction of the force on the first object is opposite to the direction of the force on the second object. Forces always come in pairs, equal and opposite. Action, reaction, force appear. How are you gonna say equal and opposite? That is not. Okay. Examples of interaction force pairs: a variety of action, reaction, force pairs. Propulsions of a fish through the water. A fish uses fins to push water backwards, but a push on the water will only serve to accelerate the water, since forces result. Wait, let's get this straight. A variety of action, reaction, force pairs are evident in nature. Consider the propulsion. The action of driving or pushing forward. Consider the propulsion of a fish through the water. A fish uses its fins to push water backwards, but a push on the water. Since forces result from mutual interactions, the water must also be pushing the fish forwards, propelling the fish through the water. The size of the force on the water equals the size of the force on the fish. For every action, there is an equal in size and opposite in direction. There is an equal in size, but there is an opposite in the directions where these sizes are. So it makes sense. For every action, there is an equal in size and opposite in direction. Reaction force. Action, reaction force pairs make it possible for a fish to swim. Consider the flying motion of birds. A bird flies by use of its wings. Qul wallah. I love Newton's third law. Lazy. تعرف معنى lazy? Lazy. المهم. Consider the following motion of birds. A bird flies by use of its wings. The wings of bird push air downwards. Since forces result from mutual interactions, the air must also be pushing the bird upwards. Consider the flying motion of birds. A bird flies by use of its wings. No shit. The wings of a bird push air downwards. Since forces result from mutual interactions, the air must also be pushing the bird upwards. Air goes down, bird goes up. The size of the force on the air equals the size of the force on the bird. Okay, I'm kind of getting the idea now. The direction of the force on the air downwards is opposite to the direction of the force on the bird upwards. For every action, there is an equal in size. Yo, can we get past this? This is really dumb. While driving down, okay, let's test ourselves. While driving down the road, a firefly strikes the windshield of a bus and makes a quite obvious mess in front of the face of the driver. Poor guy. Of a bus and makes a quite obvious mess in the front of the face of the driver. Okay. See, I did not see that. I did not notice. I want to know, why the fuck is Jimmy here giving like a wink and a smile in this situation? Is he happy that the bug died? Bugs are living creatures, you know. They have feelings. They have feelings. I don't understand. Why the fuck you gotta kill the fly? What did the fly do, Jimmy? What the fuck is... Jimmy, what did the fly do? What did the fly fucking do? Explain, bitch. I'm taking this picture way too damn personal. Let's get back to the point. Okay. Sorry. While driving down the road, a firefly strikes the windshield of a bus. Makes a quite obvious mess blah 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 front of the face of the driver. This is a clear case of the Newton's third law of motion. The firefly hit the bus and the bus hits the firefly. Which of the two forces is greater? The force on the firefly or the force on the bus? The force of the bus. What the bus? It's a bus. It's big. It's huge. It's fat. I feel like I'm describing me. The bus. Like, trick question. Each force is the same size. Fuck you. Okay, for every action, there is an equal. Okay, the fact that the firefly splatters only means that with its smaller mass, it is less able to withstand the larger acceleration resulting from the interaction. Besides, fireflies have guts, and bug guts have a tendency to be splatterable. Gee, thanks. Honestly, that's nice. Windshields don't have guts. There you have it. Bitch, what the fuck was this question? Wait. Am I learning physics? What is this? Who made this? Damn. Okay. Physics it's supposed to teach you how life works. Honestly, this taught me a lot about what happens when I get into a fight. It just tells you, people, that no matter how much you put up in a fight, you will have the equal amount of force as the person that's fighting you back. Even if it's your mama, even if it's your daddy, even if it's your papi, even if it's your dead granny, even if it's your own self, you will have equal amount of force. Only different physical interaction will be, like I said, different. And all I can say is, and both are coming in different direction. They come back, you come forward. You know what I mean? Physics. There you have it, people. We just learned the first bit of Newton's third law. I do not want to be filling up too much of this video. The more I go on with this, the more editing this will be. I'll make a part 2, but for now, this was the first. Have a good one.